There are many ways of harvesting environment energy, such as solar cells and thermoelectric generator. Other than that, without harvesting environment energy, using mechanical energy also can be used to extract and convert into electricity. Three types of different mechanisms using mechanical energy to convert electricity, such as triboelectric generator, electromagnetic generator, and piezoelectric generator. The advantages of this mechanism is low cost and lightweight, simple structures and flexibility, high efficiency and high power density at low frequency. For this research, we use the triboelectric generator as our primary research mechanisms. The research are to make a critical review about the triboelectric generator based on the objective below. First, effect of surface modification. To analyze the effect of surface modification of material combination. Next, method of triboelectric mode. To study the method of triboelectric mode on the triboelectric generator. Third, effect of different parameters. To study the effect of different parameters on the triboelectric generator. And last, effect of electrical output. To analyze the effect of electrical output by electrification based on different experiments. This is the triboelectric series chart that I use in this research. Based on the chart, the higher the series, the more positive charge we'll get. When the material at the top of the series touch with the material at the bottom of the series, they will receive a more negative charge. Moreover, when two materials of different series further each other, the higher the transfer charge. The triboelectric generator has four fundamental operation modes. First, vertical contact separation mode. Second, in-plane contact sliding mode. Third, single electrode mode. And lastly, freestanding triboelectric layer mode. So in this research, we use all the modes as our experiment research. For the methodology, we need to make a more review about the method that we can use in the triboelectric generator. So, first, wastewater flow energy harvesting method. The wastewater flow energy of the flowing water can be efficiently harvested by a triboelectric generator in which PTFE and nylon are used as the triboelectric materials. Energy is harvested by triboelectric effect and electrostatic induction effect achieved by contact and sliding mode. When water is allowed to flow through the tube, it forces the fan to rotate, which is connected to the shaft. A triboelectric material is attached onto the shaft, which rotates with the shaft due to the water flow. On the frame, different triboelectric materials are placed at 8 different poles. When the shaft rotates and the material comes in full contact, an opposite tribo charge are generated on both the surface, which result in the flow of the current. Observation shows that liquid-solid contact triboelectric generator is likely affected by humidity and friction and are capable of producing energy under harsh environmental conditions. Next, textile energy harvesting method. A triboelectric textile can be a unique source of energy in which the energy can be harvested from human motions. The charge transfer takes place between the skin and the triboelectric textile due to the triboelectric effect. A corrugated textile-based triboelectric energy generator can be fabricated capable of producing energy by stretching, rubbing, and pressing motion of the triboelectric materials. When a material is stretched, the layers of material come into complete contact, and on removal of force, it comes back to the original state. When the stretching force is applied, the steel and silicon rubber come in complete contact and electron transfer take place, which result in the production of electricity. Next, energy harvesting from walking. An experiment can be performed in which electrostatic charging occurs when two different materials come in contact and then separated. According to the result, material selection of the footwear and the flooring surface is the decisive factor for the polarity, the amount of charge built up while walking on the floor. When two surfaces come in close contact and are separated, the negative charge are produced on the PVC surfaces and positive charge are induced on the copper film, resulting in power generations. With the increase in impact force between the triboelectric material, there is significant increase in the efficiency of the triboelectric generator. Next, triboelectric generator driven by magnetic force and fingertip pressure. When the finger pressure is applied on the upper part, causing the upper pair of material to come in contact. When the pressure is removed due to the magnetic force, the lower part is pushed upwards, causing the contact of the lower pair of material. Hence, the contact and separation leads to charge transfer between the material, resulting in the flow of current. A seesaw structured triboelectric generator can be operated under different speeds and magnetic force. Magnetically coupled contact mechanism is used to reduce the weight of the materials. Rubber sponge were used for a long-term stability of the triboelectric generator electrodes. High-density sponges provide a better shock resistance, resilience, elasticity, and tolerance to the seesaw structure at high speeds. The discs were provided with the permanent magnets on the side of each disc, due to which a non-contact magnetic force acts between the discs. Next, triboelectric generator from a self-retracting dielectric sheets. A portable self-retracting triboelectric generator can be fabricated in which a flat sheet dielectric is used and rolled in the cylinder casing. The end of the dielectric sheet is attached to the inner cylinder of a spiral spring. When a user pulls the sheet, the dielectric sheet gets uncoiled into a flat sheet and restoring a force act on the sheet due to the spiral spring, which causes the sheet to roll back when the force is removed. The power is generated due to the stacking and fluttering process during the extraction and retraction phase of the sheet. The output power can be maximized by regulating the dimension of the casing material. The output increases with the number of dielectric sheets and the rotation speed. Triboelectric generator from a comb-shaped electrode and a pendulum. A simple design and highly accessible triboelectric generator can be fabricated by using a comb-shaped electrode. Its working mechanism is on-contact electrification and electrostatic induction effect for harvesting energy. The larger the number of comb electrodes are used, larger will be the energy produced. Rough surface produce more energy as compared to a flat surface. By using oscillation of a pendulum, a triboelectric generator can be prepared. When the force is applied on the pendulum, the gravity force helps the pendulum to sustain and to and from motion, producing multiple output for a single output input. For setup were prepared, among which material having micro roughness and nanowires show the maximum efficiency. With the increase in surface roughness, the efficiency increased due to the increased contact area. Okay, next, for the result. Factor affecting the efficiency of triboelectric generator. First, impact of contact forces. When the contact force between the electrode or the material is less, a lesser area is in contact, hence the triboelectric charge density is produced. When the contact force is more, a larger area of contact takes place between the material. The triboelectric charge density reaches to maximum and saturated, showing the high hysteretic behavior of the contact force response in triboelectric generator. Based on the figure, when a small pressure is applied between the triboelectric material, lesser charge density is produced due to the less contact area, while in the second case, due to large pressure, there is larger contact surface area, resulting in more charge generation. Strain in a material can solely affect the charge transfer between the triboelectric materials. Strain affects the physiochemical properties of the surface, which affect the charge transfer. In case of elastic material, when one surface of the material gets in contact with the surface of other material, strain is produced. Increasing the contact area increase the charge transfer. Greater force during the contact result in the reverse of direction of charge transfer and cause material strain. Next, effect of temperature, humidity. The charge generation between the triboelectric material increased by more than 20% when relative humidity is decreased and when the atmospheric pressure decreased to 50 torr. High humidity is not efficient for triboelectric effect and is efficient at lower pressure. A humidity-resisting triboelectric generator can be fabricated in which human biomechanical movement produce energy for small wearable electronic devices working under high humidity. The effect on the performance of a triboelectric generator over a wide range of temperature was studied by some researchers. The material properties change with respect to the temperature. With the increase in temperature, material get less ductile. At high temperature, the material get more ductile and lesser stiffer. The graph shows that with the increased temperature, the output voltage is continuously decreasing, but also depict that triboelectric generator is capable of producing output in a wide range of temperature. Third, effect of surface structure. PMMA were used as the triboelectric material, and nanopatterns were imprinted on the surface using thermal nano-imprint lithography. Different patterns were printed such as line, hexagonal cone, and filler shape, and maximum output was achieved with the hexagonal cone pattern. Fillers with the smallest weight produced the maximum output as compared to the larger weight fillers. The result of the simulation shows that the maximum pressure should be applied between the triboelectric layers. Due to high pressure, the maximum surface area will be in contact, hence maximum charge density will be obtained. Last, other parameters. A kinematic design of triboelectric generator can be prepared for enhancing the power conversion efficiency. Gear trains mechanism is used in the setup to achieve high output frequency at the lower input by using the gear. The contact type triboelectric generator is fabricated using the sliding crank mechanism from a rotating input sources because it was more effective at lower frequency. A prototype can be prepared in which rotational mechanical energy can be converted into electrical energy. When the two triboelectric materials rub each other, electrons take place between the surface of high to low electrochemical potential energy so as to reach an equilibrium condition. The current generated enhanced with the increase in angular frequency and the rotation speed. As a conclusion, in this review, triboelectric generator has been studied on the basis of its working principle, types of contact, optimization technique, surface morphology enhancement, and its application in real world. Triboelectric generator has very simple and innovative design, easy working mechanism, light in weight, and a compact in size, make it applicable to be used in every small to large power generating fields. The charge generating in triboelectric generator depends upon the effective contact area, the pressure applied, surface morphology, humidity, temperature, relative speed, and frequency of motion. A triboelectric generator is capable of working under high humidity and under a wide range of temperature region. A triboelectric generator also can be used to harvest many forms of energy from the environment, which is generally wasted, and has a very simple working mechanism. Easy design also can be used to power small wearable electronic. Many properties of triboelectric generator make it capable of producing large power and to be used in future for large power generation and different sectors like automobile, house flooring, textile, show tools for generating power in an efficient manner. Thank you.